Hey, good afternoon to you. Mark Seth with HurricaneTrack.com here with your hurricane outlook and discussion. You know what? Let's move the microphone over here. I forgot. I'm going to be on camera today. We don't need that thing sticking right in front of me. So, yeah, it's hurricane outlook and discussion time here for Monday, July the 8th, 2019, and definitely go get some reading material or whatever. Make yourself comfortable. Sit back and relax, be comfortable, whatever, because we got a lot to talk about. This is going to be a long one. So let's get rid of my mug just for a little bit and get on with the story at hand. First, we're going to talk about, I know there's a lot of interest, obviously, in 92L, but we want to talk about this because this is going to have a big bearing on the rest of the hurricane season. This is the equatorial temperature anomaly down in the subsurface of the Pacific Ocean. The eastern side of the Pacific Ocean's over here. This is the West Pacific. We're up at the surface up here and about 450 meters deep at the bottom. So this is like a slice through the equatorial Pacific. All right, and you see how this has evolved over time through June into very early July. And what has happened is we have lost all of this upper ocean heat, this anomalous heat that has been warmer than it should be. You can clearly see that has shrunk away, and now much more cold anomalies relative to average here are showing up than the warm anomalies. These are continuing to be chipped away, and so that's pretty much that. The El Nino phenomenon dwindling. We're still in this very weak El Nino state, according to the Climate Prediction Center. Bureau of Meteorology in Australia, who also follows this stuff very closely, they're saying that not so much El Nino, but whatever. So there's the subsurface. If we take a look at the actual surface temperatures here, the anomalies, that is, updated today, you can see that. There's the cold anomalies starting to come up at the surface. We're losing the warmth that was anomalous here in the equatorial Pacific. That's going away. Meanwhile, the Atlantic Basin continuing to warm throughout a good deal of the tropical Atlantic here, the western Atlantic, the Gulf of Mexico. Look at that. There's hardly any blue showing up at all. No negative or cold anomalies anywhere to speak of, maybe right off the coast of Africa. But everything else, we're talking about 95% of the ocean here where it matters in terms of hurricane development is above normal. Not exceedingly so, but above normal nevertheless. And if we expand this out and look at the broader picture, you notice colder overall look to the Pacific, slowly cooling off along the equator. And then look at all this warmth up here south of Greenland and the far North Atlantic, a little area of cold anomalies in the far North Atlantic and the subtropics there. But then down here in the tropics into the subtropics, the very southern part of the subtropics, warm. So that positive AMO, or Atlantic Multidecadal Oscillation, which is just a long way of talking about that the Atlantic is usually warmer during a certain period of time. Multidecadal, that's what that means. Oscillation means it changes back and forth. You almost have that horseshoe look. A little bit of an exception here right off the Iberian Peninsula to the west of Portugal there, but basically the Atlantic is set up, seemingly so, for it to be very busy late August through September. So we'll see. There you go. So let's get rid of these tabs. We've got a lot more to show. So actual sea surface temperatures, this is pretty eye-opening. 30 Celsius all through here, and then these little orange areas, 31 Celsius. And we have something to talk about that could take advantage of that very warm surface water. The upper ocean heat content values in this area are also fairly high. Bottom line, as I mentioned many times, especially in the off season when we're talking about sea surface temperatures and trends that they're following or not following, the Gulf of Mexico is always going to be warm enough to sustain tropical cyclones and intense hurricanes. And this is certainly no exception this year. You look at that, you say, my goodness, that is a lot of area of 30 degrees Celsius upper, well, the skin of the ocean. It really is. And then several meters deep, and in some cases tens of meters deep, that this resides, so that any tropical cyclone that comes along has plenty of fuel to work with, a lot of what we call latent heat in the atmosphere, the dew points very high, tremendous instability. It's all there and ready to be tapped into. So that's a good segue into looking at what we have from the National Hurricane Center. First of all, nothing to worry about in the Central Pacific. There's the remnants of Cosme way over on the east side, but it has dissipated. Hey, that came and went quickly, didn't it? Owed to the fact that, there's much cooler water out here, and it dissipated. So we'll be watching much more closely now, Invest Area 92L. And you can see this pretty large paragraph written about it. Bottom line is we've got this trough of low pressure, which is a focusing mechanism in the atmosphere over central Georgia, and it's forecast to move southward towards the northeastern Gulf, where a broad area of low pressure is expected to form on Wednesday, and then environmental and ocean conditions are forecast to be conducive for development, and a tropical depression is likely to form as it moves westward slowly over the Gulf of Mexico. And as you can see here, that is the general formation area. And so there you go. Now you say, well, that's kind of unusual to see this disturbance over land. We're used to seeing these pop up over water, and then the arrow will point this way or something down here or whatever, and the arrow points over here, stuff off Africa, and you see something coming out like that. Well, sometimes you do get these disturbances that will form over North America, these impulses, mesoscale convective complexes of thunderstorms. You just need some kind of a seedling. I've talked about this in the past 2 updates. It doesn't really matter what the seedling is overall. Some seedlings generate faster than others, certainly, and especially the African easterly waves, the AEWs as we call them, those that form down here off the continent of Africa and then move into the Atlantic. A lot of times those are fairly quick to develop because those are really your best seedlings, if you will. This disturbance, and I'm going to show you a satellite picture in just a moment, originated as an impulse of energy up here over the Midwest and has rotated its way south, and then eventually it will move into the Gulf of Mexico, where it will acquire more of that look. You'll see convection, showers and thunderstorms, etc., start to pop up, and you can see that as we start to look at the signature. All right, so we've got the outlook. Okay, we know something might develop. Well, where is it? What are we looking for? Well, this is a great place to start right here. I'm going to zoom in for you. Very, very clear, especially if you know your geography. There's Georgia. Now look at the roundness of that. That's very important. It's not stretched out like this, which is part of the frontal boundary. This is also vorticity or spin in the atmosphere, but this vorticity is stretched out laterally over thousands of miles. This vorticity or energy or spin in the atmosphere is more concentrated. There's not a lot of thunderstorm activity with it, but it's there. And you can see that over south central Georgia. Now, if we go and we look at it on satellite, you can really see it. I mean, come on, you don't even need me to look. You can see that whole broad turning all through here. That is this area right here. Whoops, almost had it. There we go. That's that broad turning. So all that broad energy is going to be continuing to drop south over time, and once it gets into this very, very warm and rich air mass, it'll start to develop, and the vorticity will increase around a common warm area of low pressure, and as long as the atmosphere cooperates and everything can vertically align so that you have a low pressure area at the surface and then the low pressure area in the mid levels of the atmosphere followed by a low pressure area in the upper levels of the atmosphere. When they all come together and it's vertically stacked, presumably out here over the Gulf somewhere, then the potential is there that this could become even a hurricane. That is definitely not out of the realm of possibility. So let's look at what some other people are saying about it before we go looking at the models. So from Levi Cowan a couple of hours ago, the Tropical Tidbits genius, he was tweeting that the fundamental difference between the GFS and the Euro is the disagreement of tilt. The low and mid-level vorticities, and I'm just paraphrasing what he's saying here, are currently unstacked. So remember what I was telling you, that you got to have your surface low, and then you have to have your mid-level low, and then you need to have your upper-level low, all coinciding together. And when they're spread apart or tilted, the storm is not as efficient. Remember, these are heat engines. And so that's what Levi is talking about, that the low and mid-level vorticities are currently unstacked, and northerly shear will try to keep them in that state to where everything's decoupled. The GFS develops the northern end of the low-level vorticity near Florida over here, and sorry, let me redo that, right through here, and therefore it keeps it much closer to the coast up here. This is the GFS solution. Whereas the Euro is trying to develop it down here just offshore of Tampa. And if we go up, we can see what he's talking about here. The result of this evolution is that the GFS remains highly tilted, where the mean sea level pressure center is well north of the mid-level center, while the Euro develops the low-level circulation closer to the mid-level. From the get-go, it stacks quickly and deepens. Very, very important. And let's see, I think we can scroll down, we can see more. Difficult to say which evolution is more correct, but I might give the edge to the more southern development, the Euro, since based on wind pattern for Tuesday morning, convergence, where the air is coming together, of long fetch, of richly moist boundary layer air, that's just fuel-laden air, will be focused west of Tampa, right through here, promoting convection there. And that would tend, so when you get the convection, the shower and the thunderstorm activity, when those storms go up, it helps to pull that vorticity in, generally speaking. So if that happens farther to the south over the more open Gulf, let's say west of Tampa Bay area, then we could have a real problem on our hands. And that's what Levi is alluding to here in, I think, this very informative tweet. All right, and you can read that yourself if you follow Levi Cowan on Twitter. All right, so let's take a look at the Euro. Okay, so this is the very latest run of the Ecmwf, which is the European Center for Medium Range Weather Forecasting. This is the operational model, the deterministic model. It has 50 other ensemble members where the model is run with different variables to give you a different output. For the sake of simplicity and time, we're going to just go through the Euro out to, I think, 6 days or something like that. Then I'm going to compare it with a few frames of the GFS to see if we can pick up on what Levi was talking about in that tweet. All right? So the players are, this is the initial condition, 12Z this morning. There is your vorticity, your energy over Georgia. 12Z means that this was initialized at 12 Zulu time, or UTC, which equates to 8 a.m. Eastern time. All right? So other players to watch. The outline of the ridging right here, high pressure. This is like a big bubble of air sitting out here. There's more high pressure sitting up here. And then you have this trough or this weakness in between. You see that? And it's got this little lobe, this little vorticity max right there, in between this high pressure and this high pressure here. And this is dropping south, and this is the initial condition. All right? So let's get rid of that. Now we're at 24 hours out. This is valid Tuesday morning. There's the energy dropping into the northeast Gulf of Mexico. A piece of energy splits off in the Euro and heads out to sea, well east of the Outer Banks of North Carolina. Probably some rather squally, stormy conditions associated with that. Might even see a mention from the National Hurricane Center. You never know. That is the vorticity bundling with this piece of energy, but it's going to move on out into the open ocean. All right, so that's 24 hours. Here's 48. A little bit more in the way of concentration down here. You can see the wind barbs. Everything's counterclockwise. There it is, trying to slowly get its act together. In the real world, this will feature a big blow-up of showers and thunderstorms by Wednesday morning. We should see a marked increase in storminess over the northeast Gulf of Mexico. And what's so amazing about that, we will be able to go and look at this, and at that time, this should be sitting out over here, and watch how much more red shows up you'll see this is going to evolve very interesting, and we'll be able to watch it because it's right there in our backyard, so to speak. That has its pluses and minuses, obviously. All right, that's 48 hours, okay? So that's Wednesday morning. Here's Thursday morning, and the European model showing it getting in even more so concentrated there to the south, well to the south of the Delta, Louisiana Delta, the toe of Louisiana. Storminess, certainly. Bands will be coming through, easterly flow probably at the surface. There will be impacts at this point in time. All right, and I got an email from Michael Thibodeau, I think that's how you say his name, in the Morgan City area of Louisiana. In fact, let me pull that up. I just want to read this to you real quick. And in fact, I'll bring me back on. Hi. So this is what Michael was telling me. Keep in mind that many of the rivers in the Mississippi River Valley are still above or near flood stage. And there is a river crest heading down the Mississippi River currently near Vicksburg. There is plenty of backwater flooding in south central Louisiana. Heavy rain in northern Mississippi, Arkansas, Tennessee, Kentucky, Missouri will bring rivers back to flood stage. So, this definitely could add a lot of problems, especially if this is closer to the coast like the GFS shows. So this is a pick your poison kind of scenario. If it's closer to the coast up here, much more heavy rain along the I-10 corridor. If it's farther out to sea, there'll be less of that impact, but it could get stronger. And then Michael goes on to talk about that one benefit that they're hoping for is that the toxic algae blooms that are occurring in Lake Pontchartrain and eastward, and then the nearby waters, maybe this will help to mix some of that up again and oxygenate. I mean, there's not too many better agitators of the ocean state than a tropical system. So, interesting observations from Michael. Thanks for emailing me this morning. All right, so back to this, and this is all related, as you can see. So there's 72 hours. We'll see if that's where it is, and if that's what it looks like. Here's 96. Now it really starts to come together. Much more of a signature of organization on the European model here. Finally, at day 5, this is Saturday morning, a fairly potent-looking system here to the south, well to the south of the Texas-Louisiana border, south-southeast of there. Intensifying. The UK Met model shows that as well, the United Kingdom Met model. And then finally, that's day 5. Here's day 6, Sunday morning. You see from day 5 to 6, a landfall here, if you will, somewhere in southeast Texas, the Texas-Louisiana border area, High Island, Beaumont, Port Arthur, something like that, maybe Lake Charles, hard to say. Don't focus on that exactly. You look at this and say, okay, there could be some pretty big problems headed my way, and I need to be ready for that. Heavy rain, gusty winds, maybe some storm surge. It's starting to look more probable, if that's a way to say it. It's trending that way. Why won't it just turn up into here or whatever? So we can look at the pattern, and you can see that overall, the way the pressure pattern is, there's just enough ridging all the way back over here into the western Atlantic. It's kind of like a big dude in a club, or you go to a nightclub or wherever, the crowded, football game. Get that big dude that kind of shoves everybody out of the way. And the tropical cyclone in the model here is the little dude. And it's just going to get pushed around by all this big, thick, high pressure sitting out here. And it's like a liquid acting on another liquid, okay? And that's the best way to describe it. So it's getting pushed because of the strengthening high, generally speaking, and there's meteorological subtleties to this, but for all intents and purposes, there's just too much of a high pressure area to its east. I'm just generalizing here, and this just gets shoved along until it finds the edge of that. And we can look at that closer later on, assuming this develops. All right, so that is day 6. Now, let's compare the GFS, shall we? This is the GFS at 48 hours. All right? Now let's look at the Euro at 48 hours. Euro, GFS. Different ways the model interprets everything, but generally speaking, they are both similar in painting the energy in the northeast Gulf of Mexico. You see that? more concentrated on the Euro than the GFS. Okay, now let's look at the GFS at 72 hours. At this point, most of the energy is up here, again, kind of strung out, not nearly as concentrated. So if we look at the Euro at 72 hours, it's much more concentrated and a little bit more to the south and east than the GFS. You see those comparisons there? All right. So now let's take a look at the GFS at 96 hours. And again, it kind of has a little S shape to it, that overall tropical cyclone look maybe. You know, you see that vorticity signature in there, but it's not, it's kind of hugging the coast. Maybe it's not bundled and concentrated. It just doesn't look very well organized. And so if we compare that 96 hours with the Euro, well, there's a couple of big differences. The Euro is farther to the east by just a little bit, not much, but enough so, and the Euro is certainly much more focused. And the UK Met model is along that same lines as well. We could go over these all day, and my goodness, we'd be here for another hour. Finally, at day 5, 120 hours, the GFS has this entire mess coming inland somewhere over southeast Texas, whereas the European at day 5 still lags it further behind. It's a little bit slower overall, and therefore it has more time to bundle. And this is a much more healthy looking system than what the GFS shows. You can clearly see the difference between the two there. There's the GFS, there's the European at 120 hours out. Both of these valid on Saturday morning. So what does all this mean for you? Well, you know, it's hurricane season. None of this should be of any surprise. We do get tropical cyclones that develop. That it's coming from the land mass of North America as its genesis point is a little bit unusual, but it's not completely unprecedented. And we're going to have to watch and see what happens. I think either way, we are looking at a lot of rain for areas that need it. Parts of the Florida Panhandle, for example, especially where Michael went through. You got to keep that area moist if you can. Just not too much rain. To areas that don't need the rain, like the parts of the southern Mississippi Valley, as Michael was alluding to in that email to me this morning, to the scenario where maybe there will be a hurricane threat for some part of Texas or Louisiana. Nobody has the exact answer. This is going to be a complicated overall forecast and a big headache because it's going to be so close to land, and these subtle differences, as Levi talked about, where the energy starts to take over. Does it do so, you know, up here somewhere and then kind of hug the coast? Does it take off down here like the Euro shows? That's just going to be something that we will have to watch. And fortunately, with products like this from the University of Wisconsin and the awesome satellite imager that we have, we will be able to stay on top of this and see how it evolves pretty much every step of the way, for what it's worth. I mean, at least it won't just come out of nowhere. So I will continue to watch it, obviously. I'm starting to get things ready just in case I have to leave for the Gulf Coast for perhaps Wednesday afternoon. Don't know exactly where yet, but, you know, I'll follow whatever this system's going to do. By the way, if it is named, its name will be Barry, kind of like that HBO show with Bill Hader, if you've seen that, Barry. There was a Barry in 2001 along the Florida Panhandle. I was there for that. So this will probably be a lot different, a different iteration of Barry from what we saw in 01. All right, I'll post some stuff on Twitter as well. You can follow me at HurricaneTrack. I'm also on Patreon, where I'll be posting frequently to our crowdfunding support there. And if you've ever wanted, you know, to become part of that, now's a good time to do so. Patreon.com/HurricaneTrack. I'll put a link to it in the description. Don't get too worried about this just yet. I'll let you know when it's time to do so. Until then, just keep on top of it. See what's happening. Follow your trusted sources of information. Avoid anything that looks, you know, too outrageous to be true. It probably is. And we'll just see how it all shakes out. I'll be back with more for you tomorrow. I am Mark Sudduth for HurricaneTrack.com. As always, I appreciate you watching and listening from whatever device you happen to be tuning in from. It's great to have you there. I'll talk to you some more tomorrow afternoon.